on that cumulative review. So the first one we're going to take a look at is this graph. In the first question, 1A, it says what is the range? So range, the low to high. So we could say 0 is less than equal to y is less than or equal to 7. Then write down f of 2. So when x is 2, our y value is 3. Now on the back page, write down f, the inverse of f at 2. So this is the x value of our inverse. But what does that mean for our regular f of x function? Is the y value on f of x. So when we take a look at that, let's see, where is our y value 2? Y is 2 right here, so x is 0. So this one would be 0. On the grid, sketch the graph of the inverse. So remembering, inverse is switching x and y. So if we start with this point, negative 2, 0 becomes 0, negative 2. Let's see, this is 0, 2 becomes 2, 0. This was another good coordinate right here. 2, 3 becomes 3, 2. Kind of goes out a little bit. And let's see, where does it end right here? 4, 7 becomes 7, 4. 1, 2, 3, 4. So it looks something like that. Now the next one here, on the following diagram ABC with AB 3, BC 8, ABC pi over 3, show that AC is 7. So we know it's 7, but it's saying, why is this side 7? Well, this is a law of cosines problem. So x squared equals 3 squared plus 8 squared minus 2 times 3 times 8 times the cosine. I like degrees better, so pi over 3 is 60. So let's see, x squared equals 9 plus 64 minus 2 times 3 is 6, times 8 is 48. And then we have to figure out the cosine of 60. Well, let's see, 60, opposite 60 is root 3 over 2 and half. Cosine is our x value, so times half. So let's see, 64 plus 9, so that would be 73 minus half of 48 is 24. So let's see, 73 minus 24. So x squared is equal to 49, so thus we just prove x, or side AC, has to be 7. So this next one here, we're going to use that information we had before. The shape in the following diagram is formed by adding a semicircle to the diameter. And we found before that this length was 7. So our perimeter, let's see, circumference of a circle is 2 pi r. So we just have half of that, so that's just going to be pi times r. So we would do 3 plus 8 plus pi times 3.5. So we could say 11 plus 3.5 pi. And this is a non-calculator, so we could leave it just like that. So the next one, f of x equals 5x, and we're asked to find the inverse of f. So inverse, switch x and y. X equals 5y. Divide by 5. So we have x divided by 5 equals our inverse there. Find f of g of 7. So first, let's find g of 7. So g of 7, what was our g function? X squared plus 1. 7 squared plus 1, so that's 50. So now we have to find f of 50. And what was f? 5 times our x value. So 5 times 50 is 250. This next one here, the following diagram shows triangle PQR. So we have everything labeled. Find PR. Well, this one I notice is a law of sines question. So the sine of 45 over 13, sine of 30 over x. Well, let's see, 45 sine is our y value, so root 2 over 2 over 13 equals the sine of 30. Opposite 30 is half, so half over x. Let's see, so solve this times 13 and x. So x times root 2 over 2 equals half times 13. So root 2 over 2 times x equals 6.5. Solve for x, so times 2 times 2. So root 2x equals 13. Divide by root 2. So we have x equals 13 over root 2. So our next one here, a quadratic function can be written, and it's in intercept form. The graph has an axis of symmetry at 2.5 and a y-intercept at 0.6. So I'm going to just sketch this. 1, 2, 3, 4, 5, 6. We know it crosses at, let's see, x minus 3, so it crosses at x equals 3. 1, 2, 3. And where else? Well, let's see, axis of symmetry at 2.5. So it has to fold in half along there. Well, axis of symmetry, if it crosses at 3 and that's half away from our axis, it must cross right here as well. And that's what it's saying is find p. So p has to equal 2. And then find the value of a. So now we know our equation is a x minus 2 times x minus 3. And then we can plug in the coordinate 0, negative 6. So negative 6 equals a times 0 minus 2, 0 minus 3. So negative 6 equals a times negative 2 times negative 3. So negative 6 equals negative 6a. So a would equal 1. All right. The next one we're going to take a look at, a log question here. This is one of the trickier ones in the packet. So we have to go back to our log rules where we know adding goes back to multiplying. So, problems in the packet. We have to remember for logs, when you were adding them, it goes back to multiplying. So this becomes log base 2 sine of x, cosine of x, equals negative 1. So if we were to rewrite this in exponential, 2 to the negative 1 equals 2 sine of x, cosine of x. So this is 1/2, 2 to the negative 1. And this actually is a double angle formula. So the double angle formula comes from the sine of 2 theta. Now, I'm going to highlight this because we have this 2 theta here. But if it was theta, where is our sine equal to half? Well, our sine is equal to half here and here. So this is 30 degrees, which is pi over 6, and 150 degrees, which is 5 pi over 6. So that's the angles that it worked, but that would be if it was just theta. But since it's 2 theta, so that means our 2 theta has to equal 5 pi over 6, and our 2 theta has to equal, oops, that should be theta, has to equal pi over 6. So instead of dividing by 2, I'm just going to multiply by half. A little easier there. So this means theta equals 5 pi over 12, and times 1/2 times 1/2. Theta equals pi over 12. Now the really tricky part here is it says it needs to be in between 2 pi and 5 pi over 2. So this is not, like we know 5 pi over 12 is, less than pi over 2. So let's add 2 pi to it. So our denominator, 24, that would be 24 pi over 12. So this is just like adding 360, because 24 over 12 is really 2 pi. So our answers would be 29 pi over 12 and 25 pi over 12. So this next one, f of 14. So this is a nice easy one. Plug in 14. what's the square root of 14 plus 2? So the square root of 16 is 4. Find g of f of 14. Well, we found f of 14 was 4, so this is now really find g of 4. And if we plug in 4, what was our g function? 3x minus 7. 3 times 4 minus 7. 12 minus 7 is 5. And the last one, find the inverse of g. So x equals 3y minus 7. So if we solve for y, we have x plus 7 equals 3y. Divide by 3. So x plus 7 divided by 3 equals, there's our inverse, sorry that got a little messy, of g. Here's a function again. Write down the value of f of 0. Well, f of 0 right here, nice and easy one, is negative 1. Write down the inverse value of f at 1. So this is, again, similar to the first one, x value on inverse is the y value on just our f of x function. So where is y equal to 1? Let's see. Right here. So our x value would be 2. Write down the range of the inverse. So the range is the same as the domain of f of x, the regular function. So what is, let's see, our domain? Negative 2 to positive 2. We can do negative 2 is less than or equal to x is less than or equal to positive 2. And the last one, on the graph above, sketch the graph of the inverse. So again, we got to switch some x and y's. So what is this? This is 2, 1. So it becomes 1, 2. Whoops. So that would be right here. This is 1, 0. So 0, 1. 0, negative 1. So negative 1, 0. Right here's a good one. Negative 1.5. Negative 1. So negative 1, negative 1.5. And let's see, negative 2, 2, negative 2, 2, so it would end right there. And number 9. Let ax squared minus 4x minus c, a horizontal line L intersects the graph at x equals negative 1 and x equals 3. The equation of the axis of symmetry is x equal p. Find p. So your axis of symmetry is the opposite of b over 2a. So we know it's going to be 4 over 2a. So now we have to figure out what p would be. All right, so let's see, what do we know? A horizontal line intersects the graph here. Some parabola, and this comes across and it intersects it at negative 1 and 3. Well, our axis of symmetry has to be right in the middle of those. So negative 1 plus 3 divided by 2. 2 divided by 2. So we didn't even need to do the opposite of b over 2a. We could just recognize that our axis of symmetry is in the middle, so p equals 1. Show that a equals 2. So this is our axis of symmetry, so the opposite of b over 2a equals 1. So we have the opposite of b, so that would be 4 over 2a equals 1. So times 2a, so 4 equals 2a, so a has to equal 2. The equation of L is y equals 5. What is L again? So that's that horizontal line. So what that tells us is we have a coordinate, negative 1, 5 on the graph. We also have the coordinate, what would be our other coordinate? 3, 5. And what do we know right now? So we know our equation is y equals, our a was 2, so 2x squared minus 4x minus C.